Welcome, humanoids and earthlings. As always, it's Adam and Akbar coming at you with our course on philosophy and climate change. We're in Module 2 on climate science and basic terms. This lecture, number 10, is all about those basic terms, building up our climate change vocabulary. I'm going to toggle over to the web in just a little bit here because I got a new feature. This is Akbar Digs the Data Viz. Okay, so one of the things we're learning is that we have become geologic agents, the idea of the Anthropocene. But the problem is we have a hard time imagining what we're able to do, the impacts that we're having, the systems that we're changing and interacting with. And so Akbar and I are big fans of data visualization. We think it helps to expand and grow our imagination and to just make sense of such a big topic. Plus, I'll put up another tab. I wonder if I missed a whole lecture. You know, we had climate science as a body of knowledge, climate science as institutions, climate science as methods and tools. But what about the climate scientists? Gosh, I don't know. Maybe I'll have to pick this up later on, but I want to show you just a resource where you can look at some of the top climate scientists out there. And hopefully as we go along, I'll have a chance to say more about that and those people. Okay, Akbar. But first, this data visualization. We'll talk about a carbon budget in a little bit. The basic idea is that if we're going to stay under 1.5 or 2 degrees C from pre-industrial temperatures, there's only a finite amount of carbon emissions that we can put into the atmosphere, take out of the rocks and stick up in the atmosphere. And so this is just a nice animation to show how much of that budget have we used up. And watch here, also it gives you kind of who is responsible for what chunk of the emissions, and as you see it growing, it's accelerating, so you get the sense of how much and how quickly we're burning through this carbon budget. So again, we'll talk about that later. That's a really important concept. We liked that one. Briefly, this is in your notes and on the slides. You might want to look through, you don't have to, but if you're interested in looking through some of the top climate scientists like Wally Broker and Michael Mann and others that are out there, this is a good site. It has kind of criteria, prominence in the debate, representation of both sides. This is what I want to mention very quickly, because we're going to talk about this later when we get to climate change, the media, and cancel culture. When should we allow which voices to have a platform in climate change discussions? And they have these climate skeptics that they include. I'll come back around to this at the end of the lecture, but I think what they're calling a climate skeptic is not a climate denier, and that might be an important distinction for us. Okay, but let's get into our vocabulary terms. What do you say, Akbar? Let's get a new share going here. Maybe pull this up as full screen. Boy, he's really working the technology good today. All right, today, our objective is to take stock of key terms we've already used, but I'm not going to do that in this lecture. That's in the notes for this lecture. We should be proud of ourselves. We've learned quite a bit already, and I thought I'd put a lot of that in one place just to kind of help organize what we've covered so far. Today here, I want to talk about new vocabulary terms. Like I said, it's a module about basic terms. I have some preliminaries first, and then this new vocabulary. And I've organized it. I'm not sure about my organizational structure, but I didn't want to just have a list of terms sort of willy-nilly, unconnected to one another. So I've put many of the terms under these two frameworks for climate solutions. The framework of mitigation, adaptation, and geoengineering as like the three kinds of solutions we can have. And the framework of the Kaya identity, which I'll talk through, which is another way to think about what levers we can pull to come up with climate change policies. And then just a couple of bonus terms I threw in there because they're important and I find them interesting at least. Okay, my preliminaries are simply this. Look, it's not a comprehensive list of vocabulary terms, but I think they're skeletal. They're almost like the studs in a house, you know, those wooden beams they put up. These are kind of foundational. We're going to flesh these out as we go along. So I wanted to just get you introduced to them now. So it's not the only time we're going to encounter them. So just this is an introduction. Don't freak out if I go too fast. I've got hyperlinks to information about all of these terms. We're just trying to get this introduced into our vocabulary. A quick note, of course, climate literacy and understanding climate change, which is really our overall goal, is more than just having a grab bag of terms, vocabulary terms. It requires critical thinking. How do you think through an issue is going to be more than just knowing the keywords, right? But knowing the keywords is part of it too. So let's just have a moment here and gather some of those. Yeah, and like I said, see the notes for concepts that we've already covered. I hope it's useful to put them in one place. Okay, so like I said, there is a way, one way of thinking about what can we do about climate change is to say there's three main options. Mitigation, which means reducing the amount of greenhouse gas emissions. Adaptation, which means somehow, and there's a variety of ways of doing this, of adapting our societies to the climate changes that will result from our emissions, right? So you could build seawalls, you could genetically engineer crops to grow in hotter climates. There's all sorts of things you can do that are adaptive. And these are not mutually exclusive terms. We're going to have to do mitigation and adaptation. A more controversial one is geoengineering, intentionally designing, engineering the climate to combat the negative impacts of climate change. One example is solar radiation management, where you could, for example, is literally put mirrors in outer space to reflect some of the solar radiation hitting the Earth. You can put sulfates in the stratosphere. Sulfates work also to kind of bounce solar radiation off to cool the planet. We'll talk about all this stuff later. Carbon budget, we just watched that animation. This is a way of talking about our mitigation efforts here, that there's only an allowable amount of emissions that we can produce. And so we'll come across this term carbon budget quite a bit. I also wanted you to note, you saw that bucket filling up. Well, one response is say, well, we got to stop filling it up. In other words, we're going to stop the emissions. That's mitigation. Another response is, well, what if we could drill a hole in the bottom of the bucket, metaphorically, right? And sort of suck the emissions out of the atmosphere. And that carbon capture and sequestration could be another part of a climate strategy. We'll get to those terms later. I wanted to just familiarize you with collective action problem, because I think this is another way to see it. We talked about climate change as a wicked problem. You can also see it as a collective action problem. It's a situation where individuals would be better off cooperating, but they fail to do so because of competing interests, but also because of the way the problem appears to them and what they get out of the deal and what they would have to sacrifice. You can click on that one. If you've ever heard of the tragedy of the commons, which we'll go through, this is the classic formulation of the collective action problem. And then the last concept I want to put in this bucket here, externality. Actually, I've got one more. Externality is a cost that's not included in a market transaction. And why do I put that there? Well, for any mitigation strategy in particular, the challenge is that carbon has not been priced in the economy. You know, carbon emissions in a way are basically the economy, but they don't carry a price. And so that makes mitigating carbon emissions difficult because it's sort of free to dump them in the atmosphere. So wrestling with these externalities is a huge part of climate policies. One more I wanted to put in here, and I could just geek out on this Sankey diagram, or this is an emissions flow chart. Think again about mitigation. Here you're looking at, well, where are all the greenhouse gas emissions coming from? How do we use them? Well, this breaks it down. On the left side, you've got energy at the top, and it's got it in buckets, transportation. Well, if you just eliminated everybody from driving an automobile on-road transportation, that's 9.9% of our greenhouse gas emissions. You see how this works? I'm not going to walk through the whole thing, but this is worth spending some time on just because I think it's so information dense, and it gives you just a snapshot of what's going on with climate change. It's beautiful, really. You can see if if we just fixed electricity, if we could just get carbon neutral electricity, that big red blob there, boy, that would go a long ways to solving our problems. Land use change, I just want to mention this. If you look at that green one, what's going on there? Well, primarily deforestation. And then look under that, afforestation and reforestation are negatives. So in other words, these are ways, planting trees, are ways to actually suck carbon out of the atmosphere. We should get to that later too, because how effective that could be on what scale is an interesting point of debate in climate policy. Okay, but we should move on. The Kaya identity. I'm going to have a whole lecture on this later, so again, introductory. A lot of folks don't know about this, and I feel like it's such an important, what I call a skeleton key. So what it just says, imagine you've got 4 levers to pull when it comes to climate policy. You can affect population or wealth or the energy intensity of the economy or the carbon intensity of the energy. And this is an identity because if you can see, you've got population times wealth per population, so GDP per capita. Well, the P's would cross out right there. Or then you've got that times energy per wealth. So this is how much energy does it take to produce 1 unit of GDP, 1 unit of wealth. So there your W's could cross out. And then you've got carbon per energy. How carbon intense is your energy? If you're using wind turbines, it's very low carbon intensity. If you're burning coal, it's a very high carbon intensity, right? And there your E's could cross out, so you have C equals C at the end of it. That's why it's called an identity. And these are the 4 levers. The idea is that we have to pull. We can reduce population. We can reduce wealth per population. We can make a more efficient economy that makes the same amount of wealth with less energy. And we can make energy that doesn't have as much carbon in it, right? Alternative renewable forms of energy. So it's not complicated, really. It's kind of simple, and it's nice because it puts so much into one little formula. Some terms under that bucket then that are important to know. Decarbonization. If you look at the last one, carbon per energy, if you reduce the carbon per unit of energy, that's decarbonizing, right? You can also talk about the carbon per wealth. If you reduce the amount of carbon it takes to grow your GDP, your economy, that's decarbonizing. So you can decarbonize your economy, decarbonize your energy sector. Jefferson's paradox. Look at that one, energy per wealth. That's really a measure of efficiency. How much energy do you use as an input for the output of wealth creation? And if you can use less and less energy to make more and more wealth, then you're more efficient. Jefferson's paradox is a way of saying, paradoxically, ironically, it seems like the more efficient we get with using a resource or energy, the more of it we use rather than the less of it. We'll talk about that in the future, but there's a cartoon where a woman, or not a cartoon, sorry, a commercial, a woman is asked what she's going to do with all the money she saved from her from her gas efficient vehicle. She has a Prius. And she says, oh, I'm buying tickets to Hawaii, right? So efficiency just means you save money. And if you just plow that money back into consumption, then it paradoxically might increase consumption, right? That's Jefferson's paradox. Decoupling, this is the big concept that we'll spend more time on. And this is the graph on the right here. This is the idea that what we can and what we should do on a big picture scale with climate change is decouple carbon emissions, let's say in this case, or environmental degradation, the negative impacts of climate change, from economic growth. So we can continue to grow per capita income on that x-axis. And for a while, emissions will go up, the environment will get worse. But then what you see, the turning point, that's also called peak emissions or peak impact. We'll get better and smarter, and we'll continue to grow in wealth, grow the economy, but it will be decoupled from carbon emissions and from other negative environmental impacts. This is a very important guiding sort of principle we'll think about. Degrowth is the opposite in a way. It's saying, no, you can't. We have to actually reduce the economy. We have to scale down the size of the economy. That's the only way to attack climate change. We're not going to grow, we're not going to green grow our way out of it. See, decoupling is really about green growth. And there's degrowth skeptics of that who say, no, that's ridiculous. It's a fairy tale. So we'll get into that debate later. Okay, finally, a few bonus terms. Stationarity is one I just learned somewhat recently. It means the statistical properties that govern a system don't change. So even if the system changes, the properties governing that change doesn't change. So think about seasons. The seasons change, but they change kind of in the same way, right? Well, climate change, some say, is the end of stationarity. Climate change is change in the way things are changing, you know? So click on that, check that out. I think that's a really interesting concept. And one of the things going on there is maybe a positive feedback. See, if you have negative feedback, then when something starts going up, a mechanism kicks in to push it back down. And it gets down too low, a mechanism kicks in to push it back up. And so that's your time series changing like the seasons, but they stay sort of bounded. Positive feedback is if something starts going up, something kicks in and makes it go up further. And if enough of that happens, you start getting different kinds of changes than you had otherwise. The classic example in climate change is melting permafrost. If it gets warmer and warmer in the Arctic, which it is, and you melt ice and you melt permafrost, it releases methane. Methane, more powerful greenhouse gas than CO2, causes further melting, causes further methane emissions, causes further melting, causes further methane emissions. That would be a kind of end of stationarity, and you would cross a threshold into a new climatic regime. Right? That's what some people are quite worried about. Finally, I'm wrestling with this, so I'll just put it here quickly because I'm going to come back around to it. I want to think through this with your help too. Climate change denial, I want to say, is unwarranted or illegitimate, unfounded, even conspiratorial doubt that dismisses what we've been calling the basic scientific consensus on climate change. The Merchants of Doubt is a fantastic book, Naomi Oreskes, Eric Conway, that we'll talk about, that you should check out if you have time. It's not the same, I think, as skeptics in that first tab that I showed you earlier. Although I admit this is maybe a gradation. I don't think there's an easy way to put people in boxes. At the extremes, you can. Somebody's a climate change denier if they deny the existence of greenhouse gases or something like that's clear. But what about a skeptic who says, look, I think the IPCC is just overstating the urgency of the problem, or there's more uncertainties in the climate and the IPCC models than they're letting on. Or maybe the climate isn't as sensitive to greenhouse gas forcings as we think it is. So there are ways to be skeptical but have well-grounded arguments for that. And that's not being a climate change denier. Okay, so anyways, I want to think about that a little bit more with you all as we move forward. But that's enough for now. Again, those are some building blocks. We'll keep building on them. It's kind of a skeletal architecture. We're going to see those terms again and again. I just wanted to get them cooking in your head. And boy, I tell you, Akbar, he was just on fire last night. He told me, you know that one time when Princess Leia strangled Jabba the Hutt? That's like what knowledge does to ignorance. I thought, that's quote Lord. That's good, Akbar. Okay, that's enough for now. Until next time, be good and may the force be with you.